Hello students. Today I am going to explain a topic of electric field. Okay, like you studied gravitational field, magnetic field, similarly there is a electric field. Can you tell me how the electric field produced? Electric field is produced by the charge. If there is a charge, there is an electric field, right? So today we are going to deal with that topic, electric field. Okay, so this is the introduction to the electric field. So first of all, we'll see what is electric field. What is electric field? The space around a charge in which its influence can be felt by other charged particle. Okay, I will explain in a simple words. Suppose you have a very big charge. Okay, you have a very big charge. I call this as source charge. So charge is there. I call this as source charge. Okay, very big charge. Okay, now I will place a small charge near to it. Okay, I call it as plus Q naught. Small charge, and this charge we call as test charge. Okay, for testing purpose we are putting this one. Okay, what will happen? Tell me, what will happen when I place near to it? Since it is positive, it इसके ऊपर force लगेगा. The force will be acting in this direction. Even though it is not there in contact, nothing is there. Even though if I, if I put one curtain also, you will feel there is a force acting on this charge. Why? Because of the imaginary field created that is called as electric field. Like, gravitational field is there. If I put a mass, if I leave the mass, what will happen? It will automatically fall downwards. Why? There is a gravitational field is there, which is spread everywhere. Same way, whenever there is a charge, the electric field is spread everywhere here. Because of that, when I put a test charge, and you have to note that test charge is always a positive charge. In total physics, we are taking that as positive charge, right? So whenever I put a test charge here, it is acting a force acting. Okay, why? Because of electric field. Now see the sentence, the space around a charge, space around a charge in which its influence can be felt. Influence in this case is force. This force can be felt by other charge particle placed in the electric field region. When I put a charge, there is a force acting, right? Electric field understood, right? Definition. Okay, now direction of electric field. Now direction, which direction electric field will be there? Magnetic field, if you see, or electric field, if you see, it is like towards the earth, right? I say in electric field direction I want to see. Okay, so I'll put a plus Q charge. Okay, now to understand the direction of electric field, we will place a test charge. For testing purpose we are putting. Wherever the test charge moves, that direction only the electric field will be there. Okay, wherever the force it is acting, that direction only electric field will be there. See, suppose I place a test charge here. The test charge is moving in this direction, like so. That means electric field is in this direction. If I place a test charge here, test charge is positive charge, right? So this will repel. The force is like this, so electric field is like this. So electric field is away from the charge, positive charge. Electric field is away from positive charge, or we say radially outwards. Okay, so radially outwards. This is for positive charge. Positive charge, electric field is away. Okay, similarly, if I put a negative charge, what will happen? If I put a test charge here, ये क्या करेगा? Attract करेगा. That means electric field is like this. If I put a test charge here, negative and positive will attract, right? So that's why the electric field is radially inwards. We call that as radially inwards. That means we should understand that one sentence, for positive charge, electric field is away. For negative charge, electric field is towards. Understood? So we studied what is electric field, and then we studied the direction of electric field. For positive charge, electric field is away. For negative charge, electric field is towards. फॉर न्यूमेरिकल्स के लिए ये कॉन्सेप्ट बहुत यूजफुल होगा, ये डायग्राम. ओके, चलो नेक्स्ट. नाउ आवर इंटेंशन इज टू फाइंड द इलेक्ट्रिक फील्ड. ओके, चलो, intensity of electric field length. Okay, now you understood that there is a charge is generating an electric field around it. How much electric field is here, how much electric field is there here, whether it is constant? No. As we go away from the charge, definitely electric field goes on decreasing. Okay, but I want exactly at this point how much electric field is there, what formula we have to use, we will see. Okay, intensity of electric field. So first of all, we'll see the definition. What is intensity of electric field? The electric field strength at a point is defined as the electric force acting as a positive test charge, acting on a positive test charge Q naught, placed at that point divided by the test charge. So how to find electric field intensity? Suppose I want to find electric field intensity at this point P. Okay, so what you do, you place a test charge, simple, at that point. You place a test charge at that point. Okay, now you see the force acting on, there is a force acting on this test charge, right? Because some source charge is there here. So wherever, suppose I want to find point at this point electric field strength, what is telling, first try to find the electric force acting on this charge because of some charge, some source charge. Okay, and divide with this force to the charge, we'll get the electric field. So what is saying, electric field strength, and is a vector quantity. Electric field strength is what? Force upon charge. This is a general formula of electric field strength. Suppose I want to find at this point, what you do, simply you put a test charge at that point and check how much force acting on this test charge, divide by the test charge. If you divide, you will get the electric field strength. Okay, this is a general expression, right? Now can you tell me, by seeing this formula, can you tell me the SI units of the electric field? Force is Newton and charge is Coulomb. So SI units is Newton per Coulomb. Okay, and dimensions, can anybody say dimensions? How much dimensions is there? इसका force का dimensions मालूम है ना? Force का dimension क्या है? ml t power minus 2, right? Upon charge. Charge का Q equal to IT, you know, right? Formula current electricity में we studied, right? Q equal to IT. I is ampere and T is time. Okay, so if you take upwards, क्या आएगा? M L T power minus 3 A power minus 1. Okay, these are dimensions of electric field strength. Okay, so electric field strength only we are finding in every problems mein. Electric field is general topic. It's not like, you know, electric field is there, that's it. But electric field intensity, how much, exact value is how much, we want to know. By using this general formula, we can get. Okay, now we will see. Anushka, tell here. Okay, next topic is electric field due to isolated point charge. Now exactly batao, I will take a source charge, I will put a source charge here, and exactly r distance दूर में I want to find electric field strength. So what I want, I will take a source charge, r distance दूर में I want to find at this point electric field intensity is how much. Electric field intensity is how much I want to find exactly. We'll use the definition. Before definition, we know that wherever you want to find the electric field, what we have to do, we'll take a test charge. Okay, and what we have to do, tell me, wherever we want to find electric field intensity, I'll put a test charge, and इसके ऊपर force act हो रहेगा ना, because of this देखो, the both same charges, it will repel, so some force acting on this charge, and divide with this charge, we'll get the electric field strength. That's one same procedure will follow. So electric field strength formula is what is given? F E, electric force upon charge, right? This one understood, right? Okay. By using Coulomb's law, what is the formula between, what is the force between these two charges? Anybody? K capital Q, Q naught by distance between them is R square, right? Upon, this is the electric force upon the charge Q naught. So Q naught cancel. So therefore electric field का formula आया K q by r square. K q by r square is the formula for electric field intensity. Is a scalar form. I wrote in this scalar form, but I did not wrote till now in vector form. We will write in vector form में. But here specialty क्या है? Q we should not put with sign. Okay, without sign we have to put. Okay, without sign. Suppose they will tell minus 5 micro coulomb of charge के वजह से I want to find electric field, means when you're substituting the formula k q by r square, we should not put minus. So we should put plus only. 5 micro coulomb only we should put, right? Because scalar form, right? When we are doing vector form, then only put with sign. Okay, and copied. K q by r square is the formula for electric field. In every problems we'll use this formula to solve numericals. Okay, k q by r square. Now same expression electric field due to point charge in vector form will write in vector form. Okay, so plus q charge की वजह से r distance दूर में I want to find electric field at this point in vector form I want. Okay, vector has both magnitude and direction. Vector has both magnitude and direction. So magnitude formula you know already. What is the formula? K q by r square. And you know k value, right? In electrostatics when we are studying from starting onwards, k value is 9 into 10 power of 9. Okay, k q by r square. Now this is a scalar form, and I want in vector form, right? Vector has both magnitude and direction. Direction is given by unit vector, which I will take in this direction. Okay, one unit vector r cap in the same direction. See, because of plus q charge, electric field is like this, and r vector is also in the same direction I'm taking. Unit vector, right? So I'm putting here unit vector r cap. So this is vector form, right? Now what is a cap ka formula, unit vector ka formula? In class 11th we studied, right? Vector a by mod a. Vector a by mod a is the formula. Similarly, unit vector you can substitute this one, k q by, this is nothing but magnitude only, mod r square into vector a, vector r by mod r. So mod r into mod r cube r square is r cube होगा ना, k q by mod r cube into r vector. So this is in vector form. This expression is vector form. मतलब questions में they'll give in terms of I cap, j cap, k cap, like this vector form में you can use this formula, and in this formula में we should put q with sign. With sign. Suppose minus 5 means I told you we have to put minus 5 here on. Plus 5 means plus 5 only. We get vector form. But scalar form don't take, because we will do vectorially when we are adding, it will automatically the sign direction will take care of. Okay, no need of substituting minus. Understood here? So formula for electric field is k q by r square, right? And here k q by mod r cube into r vector. This is in vector form. Okay, in vector form. Okay, we will do some numericals. उसके बाद part 2 will be coming. In that में superposition principle का base में so many questions we will do. Okay, चलो understood here? By using this formula we will solve some numericals. Okay, first question. A point charge q is equal to minus 8 nano coulomb is located at the origin. देखो, the x-axis, y-axis positive y-axis, negative y-axis is right. So at origin में the charge is placed. कितना? Minus 8 nano coulombs. The electric field vector at the point this much as shown in figure is, see that is 1.2 meters. X-axis में positive axis 1.2 and y-axis में negative y-axis में it is minus 1.6 meters. I want to find electric field intensity at this point. At this point, I want in vector form. Vector form में चाहिए. Okay, चलो. We know how to find the vector formula. Because of this charge, is telling to find electric field at this point by using vector concept. Okay, so what is the formula? Electric field in vector form is k q by mod r cube into r vector. Okay, so k value you know 9 into 10 power of 9, and q value is how much? 8 minus 8 nano coulomb, right? We should put minus or plus? Vector form है ना, minus लगाना पड़ेगा, right? So minus 8 nano is 10 power of minus 9 by mod r cube. How much distance from this charge to the point where we are trying to find electric field? 2 cube is 8. Okay, and here r vector is x में, positive x में 1.2 I cap, negative y में minus 1.6 j cap, right? चलो 8 cancel, 10 power of 9, 10 power of minus 10 cancel. So what will get? Minus 9 into 1.2 I cap minus 1.6 j cap. Now कितना होगा? Minus 1.2 into 9. 10.8. So minus 10.8 I cap minus of minus plus 1.6 into 9. 14.4. 14.4 J cap. This is the answer. Electric field, Newton per Coulomb. Newton per Coulomb. Okay, one more unit also will be coming, volt per meter बोल के. When we see the relation between electric field and electric potential, next chapter में, that time we will see this volt per meter बोल के, but Newton per Coulomb is electric field का, right? Understood? We are using vector form. Options are there in vector form. That's why we are converted into vector form. Okay. So next one. A point charge of 100 microcoulomb is placed at distance this much. Okay. If find the electric field intensity due to this charge at a point located at this point. So what is saying? Where the charge is located? Always try to draw the diagram little bit so that you will get idea. A point charge 100 microcoulomb is placed at 3 I cap plus 4 j cap. मतलब 3 I cap means nothing but positive x axis and 4 j cap is negative axis. So मान लो the point is here. Here r one vector they given. R1 vector they given. That is 3I plus 4j. And here only the 100 microcoulomb is placed. Charge Q1 मान लो. Okay. Now I want to find the electric field intensity due to this charge at a point 9 I cap plus 12 j cap. मान लो 9 I cap plus 12 j cap. Here I want to find the electric field intensity at this point P. They given R2 vector also. Okay. So because of this charge I want to find electric field at this point, right? So I want to know this displacement. R vector I want to know. We know from the vector concept mein how to find this distance. How to find this distance? R vector is R2 vector minus R1 vector, right? R2 vector is what? 9 I cap minus 3 I cap. 6 I cap. 12 minus 4. How much? 8 j cap. Okay, I want to find electric field. Electric field formula is what? KQ by R square. Right? KQ by R square. Okay. Now we know K, this mod, right? Mod R square, right? Normally magnitude we have to find. So find magnitude first. Mod R ka. So root of Cartesian form, how to convert, you know, right? 6 square is 36 plus 8 square is 64. It is 100. It is 10. Right? Root 100 is 10. Okay. Now find substitute in the formula. K is 9 into 10 power of 9 into Q. Q how much? 100 microcoulomb. 100 into 10 to the power of minus 6 by R square. R square is 100. 100 cancel. So it is 9 into 10 to the power of 3 Newton per Coulomb is a electric field. So they given options in the scalar form. That's why we convert it into scalar form. Okay. So based on the options, we can see whether it is in scalar form or vector form, or we can solve. Okay. So this is the part 1. Part 2 we will talk about superposition principles and various numericals we are doing. Okay.